Hi, my name is Gonzalo, and this is my data science specialization with IBM Capstone project. First of all, I want to thank you, IBM, for such an incredible certification. It is really complete and it helps to understand from traditional machine learning techniques to deep learning and also how to deal with big data with frameworks such as Spark. So, thank you really much for this course. The first presentation I'm going to do is the stakeholders presentation. This one is focused to a public which don't have the technical knowledge. It's going to be really short and it's going to cover three different parts. First, explain the dataset use. Second, the use case, the task we are going to perform. And finally, show the results obtained. The dataset, it's known as census dataset. Also, it can be found under the adult dataset name, and it is from the UCI repository. This dataset contains census information from different adults. This information can be, for example, their education, their work class, marital status, capital gain, capital loss for the last year, occupation, native country, their sex. So it contains a lot of information from different adults. Also, it has an output column. This column states whether an adult income is greater than 50K per year or it is lower. Here you can see some of our columns or features distribution, and also we can see the percentage of adults in this dataset with a greater than 50K per year income or lower or equal. As you can see, the dataset is a little bit unbalanced because we have 75.9% of adults with income lower or equal to 50K and only a 24.1 accounting for adults with greater than 50K income. So the use case is going to be precisely this one. Try to predict whether an adult income exceeds 50K per year or not based on census data. For this use case, we have two main components. The first one is going to be the model. The model is going to be a classifier. A classifier is a supervised learning problem which tries to categorize our inputs in different classes. For this problem, we are going to have two different classes. The first class, adults with lower or equal income to 50K per year, and the second class for adults with an income greater than 50K per year. The second component that is going to be crucial is the dataset. We need to make sure we have quality data because this data will help our models to differentiate between these two classes. So after training the models, after defining all the architecture, I have seen that we can predict whether income exceeds 50K per year with 87% of accuracy. This means we can predict whether an adult has a greater than 50K year income or lower with a high accuracy. And I have tried different machine learning algorithms. I have seen that the best ones are XGB classifier, which is a gradient boosting algorithm, also the traditional gradient boosting, and finally the multilayer perceptron, which is a neural network, which is deep learning. And even though the best one is the gradient boosting classifier, we need to also think about memory usage or performance in other aspects rather than the only accuracy. And I have tried with logistic regression or key nearest neighbor, and I have seen that the results are pretty similar, but these two algorithms, for example, have a lower memory usage. Also, I have seen pretty similar results with random forest. And finally, I have to say that I will discard the deep learning multi-layer perceptron because it is more computationally expensive than the other algorithms, but it doesn't show a better performance. Okay, the next presentation I'm going to do is target to my data science peers. In these presentations, I will try to focus on the architecture decisions, try to explain the methodology followed, and try to get a deeper understanding on the results. I'm going to skip this part because I have talked about this in the presentation for the stakeholders. It's going to be the same. The first thing is to explain the dataset we are using. Next, again, I would explain the use case, but since I have done it before for the stakeholders, I'm going to skip. And now, this is really important. This is the methodology I have followed. The first thing was to visualize the data we have, and make sure the data has enough quality to be used. After I have applied a ETL, extract, transform, load step. After that, feature engineering, which prepare our data to our machine learning models. I have split the data in two different sets, the training set and the test set. And this is a vital point because it allows us to train our model with one dataset and also have a test dataset to test our model against data that it's unseen before. I have used three different libraries. These libraries are ScienceKit-Learn, XGB, and TensorFlow. The first two libraries have been used to the traditional machine learning algorithms. The algorithms I have used are random forest, logistic regression, gradient boosting classifier, key nearest neighbor, and XGB classifier. And the deep learning algorithm I have used with TensorFlow Keras is a multi-layer perceptron. And these are the layers and the architecture of this model. And why I have used 6 different models. I have used 6 different models because I want to compare them and have different results. After comparison, I realized that the best one was XGB classifier. How do I measure this performance? With different metrics. The metrics I have used are accuracy, precision, recall, and F1 score, but I'm going to focus only on accuracy and F1 score for this presentation. As you can see in this table, the XGB classifier shows a 90% of accuracy on training and 86% of accuracy on test. It's really a high accuracy, and also the F1 score is really high. Also, here we can see that the random forest has a 100% of accuracy on training, but only 85% of accuracy on test, which could indicate we have overfitted our model. And finally, again, this is a comparative between the different models. Also, we can take into account other metrics such as the memory usage or the computation resources that each algorithm needs. But in my opinion, we should use the XGB classifier, which shows an incredible accuracy, and also it's simpler than a neural network. Now I'm going to do a walkthrough through my code. I have started with an initial data exploration. I load the data, and here you can see we have different data types. We have some numerical features. We have some categorical features. I checked that I didn't have missing values. As you can see here, these are the categorical features. These are the numerical features, and here we can see the data, the feature quality. They are all relevant because they are not correlated. Here are the distribution of the different features. This is the output column, so it's really important. Our dataset is unbalanced, and for future projects, I propose to use techniques of oversampling as smooth, SMOTE, because we can obtain better results if we have a balanced dataset. Now this is some features data distribution. I'm going to skip, and some statistical variables from the numerical columns. Okay, here you can see that in the native country column, most of the adults come from USA, so I decided to transform this column and substitute USA for a 1, and if they come from other country, set it to 0. After that, I started with the feature engineering. I used a standard scaler for numerical features, a label encoder for the target column, and a one-hot encoder for the categorical features in a pipeline. As you can see here, I split the training and data and test data. And finally, I defined the models I was going to use. And here you can see that after training its model and predicting, we have the different results. For example, gradient boosting has 87.14% of accuracy on training and 86.15% of accuracy in test. Random forest results, XGBC results, logistic regression results, KNN, key nearest neighbor, and finally the deep learning model, which is a sequential with different layers. First input layers, second dense layer with 128 neurons, after that a dropout with 20% rate layer, dense with 64 neurons, another dropout layer, and finally the output layer with sigmoid activation for classification. And here you can see the results for the neural network. I hope you have enjoyed my presentation. This is the architectural decision document. I'm going to upload it to Coursera so you can check it. And I hope you have enjoyed the time with me. Again, I want to thank you, IBM, for this course.